In number 6, we have a large right triangle, and you can see it's split into two smaller triangles. We're going to call this one the small triangle, and this one over here we'll call the medium triangle. So altogether there's a total of 3 triangles. And when we have this, and we know that they're all right triangles, so they're all similar, in other words, they're all going to be proportionate, we can set up a proportion comparing two sides from two of the triangles in order to find a missing value. And so first we have to figure out which of these 3 triangles are we going to compare, because we're only going to compare 2 of them. And it kind of depends on what information you have. You need to have at least 2 parts from a triangle in order to put them as a fraction, as a ratio to compare. So if I look at the largest triangle as an example, the only side that I really know of is the hypotenuse here. That hypotenuse side has a distance of 25. That's great, but I don't know what this side is and I don't know what this side is, which tells me we're probably not going to use that large triangle as a comparison. If I look at the small triangle over here, I've got 2 values. I've got this short side of 9 and I've got this longer side as x. And the same thing happens when I look at the medium triangle over here. I've got the short side of x and the medium side of 16. Since that small triangle and that medium triangle both have 2 values in them that are the same, we can use those. And so I'm going to, first of all, before I start trying to plug things into my proportion, I'm going to label where I'm going to put this stuff. So I'm going to put the small triangle here in the numerator, and I'm going to put the medium-sized triangle in the denominator. Okay, those could be flipped around, doesn't matter, as long as you've got a set place for them so that as we start adding values, you're consistent with where you're putting those values from specific triangles. Okay, the other thing that we have to recognize is what are we actually looking for from the small and from the medium triangle. There's 3 sides that we could look at. In both of those triangles, we said we didn't know the hypotenuse, but what we did know was the short side and the short leg and the long leg. Okay, so those are going to go up there. Again, I could flip those around. Could have had the long leg on the left, the short leg on the right. That's fine, as long as it stays consistent. Once you've got this template locked in place, now it's just a matter of plugging in the values from your diagram. So if I look at the small triangle, which is this guy over here, and I look for the short side, that's got a value of 9. And going back to that small triangle and saying what's the long leg, well, that's your x. And now I'm going to do the same thing on the bottom as I look at the medium triangle. The medium triangle has a short leg of x and it's got a long leg of 16. That was the most difficult part of all this, setting up this template for a proportion and plugging in the values. At this point, it's just a matter of going back and doing the algebra using cross products. So I'm going to do just that. I'm going to cross multiply x times x is x squared, and I know that that cross product is equal to the other cross product. 9 times 16. 9 times 16 is 144. And trying to get x by itself, I just take the square root, which will give me x, and I need to do that on the other side, which gives me plus or minus 12. It's got to be positive in this case because we're talking about a distance. So this value in here has a distance of 12.